What's up, gangsters? It is time for some mad science here at Rube Goldberg Enterprises. I mentioned in my last couple of videos that I was working on this 1/6 scale Honda Monkey, and that I had fabricated myself a sweet and tiny little clamp for the exhaust pipe. It goes around the can right there where you can see the carbon fiber decal and all that. Anyhow, so brass was a great material to make this tiny little clamp from, but as you can imagine, the real clamp is not brass. They're usually made out of some kind of mild steel that's got chrome plate or nickel plate or whatever. And then they have a rubber gasket on the inside of them to keep them from damaging the carbon fiber surface of the exhaust can. And so you can see I've got these little ridges that are, you can't see because the camera won't focus. Anyway, there's these little ridges on the side that I've added there that I'll paint black to represent the rubber gasket. But the rest of it needs to look like nickel-plated steel. So rather than try and figure out how to paint that effectively, and given that I have brass, I decided to just actually attempt to nickel-plate it. So I have bought this kit from this company called Caswell Electroplating, and this is a complete kit. It's their like educational thing, where they send you all the supplies, allegedly, we'll get into that in a second, to electroplate. And you can buy a kit that'll do gold or copper or whatever. And I bought the nickel plate kit. And so I've got these bottles of nickel plate solution and a power supply and a bunch of little gizmos. And it's time to do some science. Let's check it out. Okay, so I am going to, first of all, do a basic electroplating 101. For those who don't know how it works, what happens is that you basically have a container of liquid, and the liquid is called the electrolyte solution. And what you do is and then you have a power source. So we'll call this the power supply. And obviously the power supply has a positive and a negative coming off of it. And so what you do is you have a cathode, we'll call that C, and an anode, we'll call that A. And since power flows from positive to negative, you hook the positive to the canode, to the canode. You hook the positive to the cathode, and you hook the negative over here to the anode. That means that electric current will flow through this electrolyte solution going this direction. So what you do is you make the cathode out of the material that you want to plate with. In this case, it's going to be nickel. And you make the anode out of the material that you want the plating to go onto, which in this case is brass. So what happens is that as the current flows into the cathode, it releases nickel ions that float through the electrolyte solution and are attracted to the surface of the anode like that, and it becomes plating. It's a pretty simple process, really, and it was invented a couple hundred years ago, and has become one of the most important industrial processes that we use. So that's how it happens. And they have allegedly given us all of the supplies that we need in this little kit for about $70 to do that. You get 2 bottles of the plug-and-plate nickel solution. Now, I should say up front that you can do all this DIY. There are plenty of videos on YouTube that will tell you how to make the nickel electrolyte. You can use any old power supply, blah, blah, blah. But I didn't want to do all that. Just too much energy, and I just wanted to get straight to it. And I was going to have to buy a power supply and nickel plate, anyway. So I just thought, well, might as well get this kit, which, as you can see, contains a plastic beaker, 1 pint of the electrolyte, 2 small anodes, which are these nickel plates here, and a copper wire, and a wooden stick, which I was supposed to use to hang the workpiece off of, and some wires to connect everything, and this little power supply. Seems simple enough. So what they want you to do is, first of all, you're supposed to pour the solution into the beaker. I obviously haven't done that yet. But then they want you to take a pair of tin snips, and these nickel plates start out flat, and they want you to bend these little ears off of each side so that it will hang off of the sides of the beaker. Now they tell you to cut a 1/8 inch slice about 1 inch long on each side of each anode. Well, if you do that, it doesn't work because the plate goes straight across here, and these little ears don't reach the edge of the beaker. So that's why I bent the plates the way that I did, so that they kind of fit the inside of the beaker a little bit better. So they are in there. And then they give you this jumper with 2 alligator clips to connect those 2 anodes together. So that part of the setup is pretty straightforward. Then they want you to attach the alligator clip to the banana clip on the power supply, and that's what we've got here. So you can see that just pops off of there. You just plug that in, and that part is ready. So now you have, I don't know why they did it that way. I don't know why they didn't just give you 2 alligator clips, but whatever. Anyway, now we have the 2 alligator clips from the power supply that we will connect to the electrodes, or to the cathode and the anode in the vat. Now, then they talk about part preparation here. So the first thing they say is that your part will electroplate regardless of how clean it is, but it'll delaminate if it's not grease-free. So first thing they want you to do is get your piece clean. Now, I'm not going to just jump right into attempting to plate my little exhaust clamp, because I spent way too much time and effort making that thing to screw it up. So what I'm going to do first is I've cut a brass strip that's about the right size, and I'll explain the size thing here in a second. First thing I'm going to do, though, is clean that off. Now, this is kind of goofy. While wearing gloves, clean your part. Avoid any petroleum-based cleaners such as lacquer thinner. Well, guys, you may know a lot about plating, but you don't know much about paint supplies, because lacquer thinner is not a petroleum product. It is something else. Alcohols, xylene, acetone, stuff like that. And it is a wonderful degreaser, and so I am, in fact, going to use lacquer thinner on the test piece to make sure it is grease-free. And hey, look, if it is actually, truly not a good thing to use lacquer thinner, then we'll find out here in a second. So that's clean, grease-free. Then they want you to rinse it thoroughly in water. I'm not really sure. Well, and then see, I just put my greasy paws back on it. Got it dirty again. So here we go. Back with more lacquer thinner. I'm just going with that. I'm not going to rinse it in water. That doesn't make sense to me. So, okay, now attach your cleaned part to one end of the copper wire. Make sure it is secure. I think what I'm going to do, well, here, before I do that, I'm going to go ahead and add the electrolyte solution to the little tank here. So I'll be back in a minute after I get that done. Okay, so I now have the tub full of electrolyte and the workpiece suspended inside of it. And it looks, you know, hanging from the little wooden stick, just like they say. So what they want us to do next is to connect the positive, which is the red alligator clip on the power supply, to one of the anodes. So we'll be plugging that in right here, and then plug and make sure that it's connected outside of the beaker. That seems kind of obvious. Connect the negative, or the black alligator clip, to the copper wire. So we would be plugging that in right here. Either connected to the hook on the tank bar or just below the tank bar. It should not be in the plating solution. Then plug in the power supply. Now, here's where things get a little sketchy, because as straightforward as all that sounds, there is an important disclaimer here at the end of the instructions that is not, of course, in any of the stuff you read when you buy this kit. Okay, so here's what it says right here. Electroplating to achieve polished and attractive parts is achieved by first polishing the cathode before electroplating. Just like painting a car, if you start with a bumpy, badly prepped part, you will end with the same. Dremels or small bench grinders can be used to polish small parts, blah, blah, blah. Well, my workpiece is very shiny. That's no problem. That's not the part of the disclaimer that's the issue. This is number 2. Best results will be achieved when controlling the amperage applied to the part during plating. Nickel plating prefers 70 milliamps of DC current per square inch of part surface area. The power supply in this kit supplies a fixed 300 milliamps. Build a rheostat to control the amperage. Yeah, I don't know about you guys, but I don't just build rheostats. They act like this is an everyday thing, and maybe in science class it is. But here's what it says in the troubleshooting down here. This is why this is important. Too much current causes blisters and peeling. Build a rheostat or add additional parts into the beaker to rob the excess current. So, yeah, well, here's the deal, all right? If you take the fact that this clamp has a circumference of about 1.5 inches plus the little ears, about 1.75 inches, it's about 2 inches wide. I mean, not 2 inches, 0.2 inches wide. And multiply that by 2 because you have to account for both sides of the clamp. Well, that's about 3/4 of a square inch. And 3/4 of a square inch, if you need 70 milliamps per square inch, equates to about 50, I calculated it out to exactly about 56 milliamps of current, ideally to plate this tiny little part. Well, but yeah, hold on a second. This thing says pretty clearly on the back that it is a 300 milliamp power supply, allegedly constant. Yeah, so what do you do if you don't just build rheostats on the fly? Well, you need an important accessory that I just happen to have called a good buddy who's an electrical engineer. Hey, electrical engineer, come in here and say hi to the folks.
Hi, folks.
Okay, so I have an electrical engineer, which is quite possibly the most important accessory in this entire project. And we brainstormed and thought, well, okay, well, actually, here's the reason why I took advantage of the fact that my electrical engineer buddy was coming to visit this weekend, was I knew that he would have a whole box full of electrical engineer shit. Well, he did, and he was going to bring it, but he forgot. Yeah, bad electrical engineer friend. So then we brainstormed and we thought, well, what is a rheostat if nothing more than a variable resistor, right? Is that correct,
That's
electrical
correct.
engineer friend?
Yes,
okay.
it is.
So I thought, well, you know, you can order rheostats anywhere. I mean, you can get them for like $15 off Amazon. But of course, that was too late. And like all dudes, we don't want to wait to do our project on a Saturday. So we stopped at the home improvement warehouse and bought a dimmer switch, which to my mind was, what else is that but a variable resistor. I have no idea what I'm talking about. I just know that things like volume knobs on old radios and stuff like that were rheostats, also known as potentiometers. So we thought this would work, but what happened when we put the multimeter on this thing and turned the knob, even with it plugged into the power supply, because we thought we could just put this in series, which means in between the power supply and the anode, and we would reduce the current. Well, okay, I thought that. My electrical engineer buddy knew better. Anyway, yeah, it didn't work. And part of the reason is because this is maybe not an old-fashioned rheostat. Maybe there's something more inside of this little box that is fancier, and it only wants to see 120 volts. So, yeah, this is probably not going to work. Although, I had an idea while I was sitting on the toilet a little while ago, because that's where all good ideas happen, right? Hey, engineer friend, what happens if we plug the thing that wants to see 120 volts into 120 volts and then connect the power supply to that? So basically put the power supply downstream of this gizmo, thereby feeding it a reduced whatever. Would that work? He's raising his eyebrow, guys. It's not looking good.
It's worth a try if we're not in the room when we energize it.
Okay. Yeah, he also happens to be a professional electrician, so yeah, I'm probably going to listen to him on that one. Anyway, so what we're going to do is we are going to just go for it with the test piece and see what happens when we give the little tiny test piece the full juice. Don't plug that in just yet.
I'm not willing.
Yeah.
I'm just getting wires.
Yeah, see, I get really freaked out about electricity.
I do too.
Yeah, but he's the kind of guy who like will change out an entire wall outlet without even turning the power off because he knows what he's doing. I get freaked out just being near things, even if I know for a fact that they're not plugged in. Yeah, this is one of those deals. This is classic Rube Goldberg shit right here, because I'm just certain that there are going to be sparks, and we're gonna blow some shit up. I'm not. The fact that this is. See, I'm a mechanical engineer by training, and I don't like stuff that's janky, because that's when shit breaks and people die. And I'm pretty. See, the thing already fell in. The solution. It's already off to a bad start, and my anxiety level is already extremely high. I'm expecting drama. Okay, so we're back. I had to take a break and do a little farm boy engineering and make this thing a little more stable so that it would not slide over and, you know, electrocute me or anybody else. And we think now that the thing is good. So we are about to plug this in and attempt some benchtop electroplating. And I'm going to adjust the camera here a little bit. I don't want the camera directly above for when it explodes. And because I'm like 100% freaked out right now, I'm scooting back, and the resident electrical engineer is going to plug the power supply in. And here we go. If there's a blinding flash and you never see me on YouTube again, you'll know why.
You don't want to...
Okay, yeah, I'm going to scoot over further away. Yeah. Okay, go for it.
Alright, we're energized.
Well, that was anticlimactic. And it is, aha, but look, it's bubbling. You guys can see it. Yeah, it is definitely doing something. There's much bubbling happening. And we're now going to measure some current. Yeah, see how confidently he just reaches in there to touch things that have deadly voltage running through them?
3 volts.
So we have 3 volts, which is what the power supply allegedly puts out.
Actually, it's millivolts, Bill.
It's what?
Millivolts. That's very, very low.
I thought the power supply said it was like 4.5 volts.
It did. I may not be making good connections.
This power supply we think is some sketchy Chinese thing that does who knows what. So 4.8 volts. Yeah. So yeah. See, this just freaks me out. I'm not. Yeah. I just no. Electricity, no. It's my hair's standing on end, and I'm not anywhere within a foot of that thing. So anyway, what we're going to do now is we're going to just let it run for a while. It is 3:05 in the afternoon, so we're going to just let it go for a little bit. They don't really say in the instructions how long this should take. Well, no, actually they do. They give you a rate. With this nickel electrolyte, plating rates of approximately 1/1000th of an inch per hour can be expected. So, I mean, a 1 mil thick coating sounds nice. That's probably a lot more than you really need, but at any rate, we're going to let this sit here for a while, and then we'll come back and see what happens later. Okay, so it is about 30 minutes later, actually 40 minutes later, and I've unplugged the power supply, and I'm going to take this out, and we'll see what it looks like. See if we have successfully nickel-plated the brass strip. So it's kind of got a greenish silver tint to it, and so you can see there what it looks like. That looks nickelish to me. So let's get in close for a good look. Not bad. Okay, come on, camera. Focus up. That's not bad. I mean, it's not shiny, but I don't think I really would have expected it to be on this just stock brass strip that hadn't been polished. You can see there's some texture there. I think I actually would be okay with that look for my clamp, because it's legit. It looks authentic. It looks like real metal, because it is. So I think I'm surprised. I took the instructions at their word. My electrical engineer, Jeannie, was unconvinced that it was going to be a problem, and he talked me into just trying the test strip with the full 300 milliamps, and he was right, because that looks fine. There's no bubbling or flaking or anything weird after a half an hour, so I think that's pretty dope. And dope enough, in fact, that I think I'm going to just go for it. I think I'm going to just put the clamp in there and do it. So I'm going to clean this up. I'm going to put it in the plating, and we'll come back in another 30 minutes and see how it looks. Okay, so it has been just over an hour, and I have unplugged the power supply, and it is time to, it is the moment of truth to see how the plating did on this. So there we go, that's out. It's looking like it's got a lot of electrolyte on it, but otherwise seems okay. I don't see any obvious bubbling or anything like that. So let's clean all that off. I don't really know what the best way to get that electrolyte off of there is, but I'm going to start with water and a paintbrush. Yeah, that's going to work. See, that's already starting to come off of there. See, yep, good. I hope this works. I hope this was all worthwhile. I thought it was a really cool idea. But cool ideas don't always turn into cool results. So we'll see what happens. Not bad, not bad. It's basically, it's dull gray like the test piece was when I took it out, but I don't see any defects, and that was my main worry, is that based on what it said in the instructions that I might have some of that bubbling or flaking or whatever, and it doesn't look like I do. Looks like I have a pretty uniform gray finish, and like I said with the test piece, I could live with that, but in the meantime, while this was working, I rubbed on this test piece a little bit, and you can see the result there. I mean, that's just basically sanding it with a 800 grit sanding stick. And that's not a bad finish at all. I mean, that would be totally fine with me for that muffler clamp. So I think it's going to be fine. I'm pretty stoked. And so what I'll do is do the rest of the cleanup on the clamp off camera, come back, take a final look at it, and I'll show you guys the results. Okay, so it is the next day, and I have cleaned up my little clamp, brushed off all the residue from the electrolyte, and I think it looks pretty good. It was super dull when it came out of the solution, but it's pretty legit now. I like it. And I think it's going to look really nice when it is all put together with the carbon fiber muffler can and the carbon fiber hanger for the muffler. So overall, I feel like this was a success. It's not perfect. You can see on this side where some of my solder residue that I thought I had gotten completely rid of showed up. But that's okay, because that'll be on the side that nobody can see. So I'm going to be okay with that. Now, you might be thinking, well, you went to all that effort and you didn't get real chrome. Well, yeah, and I knew I wouldn't. Okay, this being real chrome, triple nickel chrome to be exact. And the reason that you don't get this from what I did with this little clamp is because this is a three-step process that involves plating the original part with copper, then they put the nickel on it, and then they do a flash with chromium. And that's what gets you that real super brilliant reflective look to it. So it's just a different process that I don't think I'm capable of duplicating. But that's okay, because I didn't really want a chrome bracket. I just wanted one that didn't look like it was painted, and I've definitely achieved that. Okay, so there it is. Operation Electroplate is done, and I think it was a success. Now, I know that some of you guys are scratching your heads or shaking your heads and saying, why? Why would you spend $70 and all that effort just to put a silver finish on your little clamp when you could have just painted it? Well, yeah, I could have just painted it, but there is no substitute for a real metal finish. And yeah, I know there are going to be people who are saying, well, I just use all clad, or I just use whatever metallic, and I've never had any problem, looks great to me. Well, okay, perhaps. But I really feel like that in scale modeling, that there's a lot of brainwashing that's going on when it comes to metallic finishes. I mean, when all you've got is McDonald's, you know, then sometimes a quarter pounder seems like gourmet food because it's got special sauce on it. And I kind of feel like it's that way when it comes to metallics in scale modeling, because all we really have are painted imposters for things like chrome and aluminum and steel. And so when you get really good paints and somebody does a really good job, it looks like it's got special sauce on it, and everybody freaks out and is like, oh, that's amazing, how did you do that? And it is, it's fine, it's cool. I mean, it is what it is. We have limited resources and a limited ability to produce realistic metallic finishes. But I wanted more, and the fact is I like to experiment, and now I've got an additional tool in my arsenal that I know that I can use on just about any photo etch or brass part that I may scratch build, where I can give it that same type of a steel appearance, and I think that's cool. So this won't be the last thing I use it for. Anyway, I hope you guys thought this was cool. I know it was kind of a little bit specialized, but anyway, these are the adventures of Rube Goldberg. All right, I appreciate you watching. Much love.